Podcast is now starting. All attendees are in listen-only mode.
Hello, everyone. I want to thank you for joining us today for our CAD/CAM in Education webinar. My name is Don LaCourse. I'm a Senior Application Engineer here with MecSoft Corporation, and I'm joined today by Joe Anand. Joe is MecSoft's Product Manager, and let's jump right in. Okay, a few housekeeping tips. We are recording this webinar, as we always do, and we will make it available as a download to you, typically within 24 hours, but it may take, it may take 2 days, but typically sooner than that. And we're going to reserve the last 10 minutes of the program for questions. So you see the chat window dialog there on the screen. If you got any questions, just type them in there, and Joe will be monitoring the chat session in the background and answering questions. So feel free to ask any questions you might have. Okay, what are we going to talk about today? Our agenda, initially we're going to talk about MecSoft Corporation and give you a short introduction about the company and its products. And then we're going to jump right into two very cool presentations from Sisters High School in Sisters, Oregon, our first presentation, and also IYRS School of Technology and Trades in Newport, Rhode Island. And then we're actually going to take a look at those two student projects in both Visual CAD/CAM and in RhinoCam. And then we'll also do a recap of MecSoft's educational products. Now, I wanted to stop here and just mention that if anyone cannot see my screen or if you can't hear me, please enter that information in the chat window and we'll get any technical difficulties straightened out. And also there will be a short delay when we change screens, so I'll make sure to compensate for that. Okay, Joe, you want to handle this part?
Yeah, thank you, Don. As Don mentioned, my name is Joe Anand. I'm the product manager here at MecSoft. Anita was supposed to have been running this webinar, but unfortunately she called in sick, and so I'm taking over here. She sends her best wishes, though. So yeah, I'm going to do the front portion, basically talk a little bit about MecSoft Corporation, and then hand it over back to Don, who's going to be actually doing the presentation and the show and tell. So very quickly, MecSoft Corporation, for those of you who don't know who we are a CAD/CAM company, primarily specializing in CAM software solutions for the CNC numerical control manufacturing in a wide variety of industries. And as you can see in this graphic, there are a whole host of industries that we target, and we have customers successfully using our product. And then education, you'll see education as well as a big market for us, as well as a large installed customer base in the education marketplace. So aerospace, automotive, production, musical instruments, woodworking, jewelry, not so much these days because a lot of them are using 3D printing, mold and die, prototypes as well, robotics, robotic milling, and then educational, as I mentioned. So Don, if you want to flip over to the next slide, please. So we'll talk, we have, as far as our notable customers, we have commercially as well as educational customers. We have over 10,000 customers spread over 50 countries around the globe. And so we have resellers outside the US to sell and support our products. Our customer profile typically is entrepreneurial shops, small mom and pop shops, and all the way up to Fortune 500 companies. In fact, even Fortune 50 companies like Exxon and GM and some of these large companies do have our products. In fact, GM has about, I believe, about 15 seats of our product. The characteristics of our customers are typically they're very loyal, passionate, and repeat customers. So we have a lot of them coming back and upgrading to the latest version, and a lot of our customers are on maintenance service because we do offer a lot of maintenance service perks which help these customers get very productive and keep their productivity up with our products. And then, as I mentioned earlier, we have a very strong educational customer base all over the world. In fact, in the US, most universities use our product because of our association with Rhino as well as with SolidWorks. We really are the go-to company or product for CAD in the educational market. Next slide, please, Don. A little bit about our products. The slide is a little busy, but let me explain. The top graphic basically talks about our product, the different products that we have. On the bottom, the boxes that you see are the technologies that we have. So our flagship products are Visual CAD CAM and Rhino CAM. Visual CAD CAM is our standalone CAD, includes our standalone CAD, and it's got all modules for shop floor and general machinists. It's a very if you're starting out in CAD CAM, like most people in high schools do, or most students in starting out, this would be an ideal solution for you. And in fact, Don is going to be talking about that down the road, about how a high school has adopted our Visual CAD CAM product in their curriculum. And Rhino CAM, which is our other very strong product, runs inside of Rhino, is a plugin that runs inside of Rhino. And so you would need Rhino for you to be able to run Rhino CAM. So the combination of Rhino and Rhino CAM, again, is very powerful. I mean, if your school wants a very high-powered CAD system, a free-form modeling system, as well as a very high-powered CAM system, this would be the combination to go for. And then we also have two products that are targeted at the parametric systems, like SolidWorks and LibreCAM. These are more engineering-oriented CAD systems, so you can use parametric design and variational modeling and things of that sort to help you with engineering designs, more for production machining and things of that sort. And we have plugins that run both inside SolidWorks as well as a Libre, and that might be an option if you're in a university doing engineering or manufacturing engineering curriculum development. And then finally, we have a companion product called Visual CAM C for Onshape. This is our latest foray into the cloud. This is a companion to Onshape. You might know that Onshape is also a parametric system, but it's completely cloud-based. So we came up with a product that's based on our Visual CAD CAM technology to run on the cloud, exclusively on the cloud. So that might be an option as well for some students who might be looking for an entry-level option for CAM. As far as our technologies down at the bottom, of course, CAD, which is included in Visual CAD CAM. And then we have a mesh module that allows you to take, mesh data, unordered mesh data, and clean it up and make sure it's good for machining. It's a pretty nice, you can do decimation, you can do refinement, and a lot of those, even work with point clouds and create meshes out of point clouds. And then, of course, for the milling and the turning, those are our machining products that target both the CNC milling centers as well as turning centers. Then we also have a parts nesting product that allows you to do parts nesting, both true shape and block nesting, which is block or rectangular nesting. And then we also have an artistic modeling product that can help you with bitmaps. If you're working with bitmaps, you can create 3D models out of bitmaps and things of that sort. And then finally, we have a 3D print add-on as well. So if you're using an SLA printer, you'll be able to use our 3D print product using G-code to drive the 3D printer. So that's in a nutshell our products and our technology. So Don, next slide, please. So now we are at the guest presentations. So Don's going to be taking over here and talking about two of the case studies that we have done, one with a high school and one with an university. So it's all yours, Don. Okay, everyone. We're going to start out with Sisters High School in Sisters, Oregon, and let's take a look at their really cool program they got going on, integrated with Visual CAD CAM.
So this slide here, you see on the left, we see the subject part that we're going to be taking a look at. It's a ukulele neck, and on the right, you see then Governor Kate Brown of Oregon holding that specific part in her hand and talking to one of the students. So I'm gonna explain that a little bit more here in just a second also. Okay, where is Sisters High School and what do they do? Okay, Sisters High School is located in Sisters, Oregon, the town named Sisters, and it takes its name from the nearby Three Sisters Mountains, the mountain range. And Tony Cosby is the technology instructor at Sisters High School. And Tony teaches beginning and advanced woodworking. He teaches construction and introduction to engineering and design through a program called Project Lead the Way. You may be familiar with that. That's a curriculum that is written by actual engineers for high school students. And so what do the students do? They manufacture ukulele and luthier guitars. Now, we're talking from start to finish in the, I believe it's a 2-year program. So at the end of the 2-year program, they're going to have a completed guitar. So since introducing the luthier program in 2005, each class has averaged 30 instruments a year. And then at the end of the year, students can keep their instrument, obviously, or they can sell it at a fundraising auction for the school. Now, the program also, Tony is assisted by Jason Bowerman of Breedlove Guitars. And also he has a team of 12 dedicated on-site volunteers. Now, you can just imagine the size of this program. Tony and 12 other people helping students build guitars, and it's pretty awesome. Let's go to the next slide. Now, I mentioned then Governor Kate Brown. Why is she at Sisters High School? Well, the program at Sisters High School has been so popular. It's like the thing in the town that's talked about. If you're anywhere around Sisters and you're familiar with the high school or with the students there, you know about this program. And then it's also been picked up locally through news presentations. The local news stations have talked about it. And that's where it came to the attention of then Governor Kate Brown. And she wanted to visit to see what this program is all about, why was it so successful, and how she can possibly implement this program statewide to all high schools throughout Oregon. And that's pretty exciting. Now, this is the part we're going to look at. What you're seeing here is visual CAD cam. We're looking at the CAD part. This is visual CAD. And the part, Sisters High School actually has multiple seats. They have visual CAD cam, and they also have visual cam for SolidWorks. So this part came out of SolidWorks and loaded up into visual CAD. And as you can see, it's a 3-dimensional neck of a ukulele guitar. Now, here is another slide of Visual CAD CAM. This is a cut material simulation in Visual CAM, which is the plugin that runs inside of Visual CAD. And we're looking at the initial horizontal roughing toolpath, or also referred to as Z-level roughing or roughing in levels. And here on this screen, we got the Z-level display dialog shown, and we're looking at level number 7 in the cut material simulation. Okay, what's interesting about this part as far as Visual CAD CAM goes, other than the fact that it's a cool 3D part, it's a guitar neck, and it's going to come out looking very well. But what's interesting about this from a CAM standpoint, from Visual CAM inside of Visual CAD. So if you look at the two inset images, The one on the top is 3-axis Z-level roughing. I mean, sorry, 3-axis Z-level finishing. And if you're familiar with Z-level finishing, it slices the part in the XY plane at a given distance between levels in the Z direction. So what happens there is if you have a part that has flat areas or near flat areas, you'll see, and you start to see it here in this top image, the cutter path will leave cusping that you'll have to come back with a separate operation and clean that up. However, in Visual CAD/CAM, you have an option called Optimized XY Machining. And this is just a toggle. You just turn it on inside of Z-level finishing, and you tell it what your step over you want it to be. And it goes in and calculates additional tool paths and places them between the Z levels. So you see here, we got a big area that's leaving a cusping. So down here, you see that all the XY passes that the program calculated that it needed to clear all that material out. And we're going to be taking a look at this part specifically in just a second. Okay, obviously, when every user that we talk to, our main question is why? Why are you using our product? Why aren't you using a competitor's product? Why are you still with us? And we get a lot of different answers, but they tend to boil down in two main areas. And for Tony, I'm going to paraphrase him here, and you can read it here in the background. Primarily ease of use for Tony. He's working with high school students. So these are young students, sharp minds, but they have never been introduced to anything close to CAD or CAM. So Tony has, talked with other instructors in nearby schools, some who have master CAM. And the kids there are struggling greatly. So if you can imagine a high school student trying to understand master CAM in order to get his ukulele guitar neck machined, it's a big struggle, and they're just bogged down with it. So as Tony says, it takes a lot of time to learn new software, and when he finds something that both works and is easy to use, he stays with it, and that's his main reason. Now here, these are some cool inlays. Each student, as I said, gets to build their guitar from start to finish, and they can choose from different designs, different body designs, different inlay designs. And for those of you who may not be familiar with inlays, basically you're taking composites of materials and you're machining a pocket, and then you're inlaying that secondary material into that pocket. So if you see here on the left, this is a very, very intricate inlay design. I mean, for a high school student, it is phenomenal. You see that you have the base wood of the body, and then you have two different woods, one the outer ring, and then another wood for the inner ring. And then you have mother of pearl that's inlaid around the inner wood composite in a lace pattern. Now that is a very, very complicated inlay, and it looks beautiful. And then on the right, this guitar has this student has chosen to inlay a hat, which typically they're out west, so a lot of them are wearing cowboy hats. Okay, so let's go to the next slide. Oh, I wanted to mention here that if you see this link here at the bottom of the slides, you can go to this, you type in this link in our website, and you can see the full case study for Sisters High School. Now on this slide, on the left, you will see another beautiful inlay. We see two different types of wood, the bass guitar, and then the profile of the Sisters Mountain Range, and a secondary wood on the bottom, and then also a starburst inlay around the opening here. Now on the right, new students that come in to the program, the first thing they do is they take a tour of the shop. and they can look at all the different components that make up their ukulele guitar. So they can choose, their design. They can choose a body style, they can choose a neck style, they can choose the inlays, the bridge types, all kinds of things. So they do that initially, and that's what these students here are doing right now. Now I like this slide. Look at all those happy faces, and Tony Cosby there sitting down in the front. This is at the end of their program in 2015 to 2016. Everyone's standing up and showing off their guitars. All of the parents are in there watching, and the kids are just having a great time. And you can tell they put a lot of sweat and effort into this guitar, and they like it. So that's cool. And at the last minute, I slipped in this slide just to give you an idea of the Three Sisters Mountain Range in Oregon. Now that's beautiful.
So Don, I just put the PDF link for the case study in the chat window.
Oh, great.
So just for the reference for our audience. So
okay. Thanks.
Hopefully you can link. Okay.
Appreciate that, Joe. Okay, so let's keep going. And if you want to get more information, as Joe mentioned, he put the link to our case study there in the chat window. Also, if you want to go and get more information online about Sisters High School, you can visit them at shs.ssd6.org, and that'll take you right to the Sisters High School website. And then obviously, if you want more information about Visual CAD/CAM, you can go to mecsoft.com/visual mill, and that'll take you to the Visual CAD/CAM product page. Also, I wanted to stop here and just mention, if anybody has any questions, please do type them into the chat window, and Joe will be monitoring them in the background. Okay, that was Sisters High School in Sisters, Oregon. Now we're going to move all the way across the United States to the Eastern Seaboard to the New England area. And we're going to talk about IYRS School of Technology and Trades. Now, what does IYRS stand for? Well, it stands for the International Yacht Restoration School, and that's in Newport, Rhode Island. And this is a pretty nice, cool case study here. Now, what do? IYRS is a nonprofit post-secondary experimental learning school in Newport, Rhode Island. The school offers education and training in shipbuilding, restoration, composites, marine systems, digital modeling, and fabrication. And Kelsey Britton is the program manager and instructor for the composites program. The first year in this program, the students build a complete BeetleCat sailboat. I'm going to show you that in a minute. So actually, they make a sailboat from scratch to sailing in the first year. In the second year, they come back and they refurbish the BeetleCat sailboat that they manufactured the previous year. So the boat has been in dry dock for a year, and then they come back and they learned boat building restoration techniques. A little bit about Kelsey. Kelsey, she is actually an IYRS graduate. She initially graduated and did some other things in other industries, but she was always brought back home and loved the boat building industry. And she was actually offered a teaching position at IYRS because she excelled so greatly in the program. And you could say that boating and sailing is in her family's blood. She was taught how to sail by her mother when she was just a young girl. Her brother is a ferry boat captain in New London, Connecticut, and her father is a marine mechanic and manager there in Newport, Rhode Island. And also, Kelsey mentioned here, we sat down with her and had a long discussion interview with her, And she mentions that she uses our articles on the MecSoft Tech blog actually to teach her students how to be proficient in RhinoCam. So that's pretty cool. As I mentioned, the first year students, they actually design and build their own sailboat. And on the top two images, you see students actually on the drawing boards designing a BeetleCat sailboat. And that's primarily the reason why they use Rhino, because Rhino CAD modeling is so proficiently used in the boat building industry. And down below, you see two examples of some BeetleCat sailboats that were designed and built by students and then sailed at the end of their first year. Now, why am I looking at a bicycle helmet? Well, at the end of the program, students can choose any project they want to be their end of year program, and it's going to count for a large part of their grade. So we're talking about the composites technology program where where RhinoCam is used proficiently in the composites class. So student Wyatt Jeffries is an avid bicyclist, so he wanted to design his own and manufacture his own bicycle helmet. So on the right here, you see the RhinoCam part of the helmet, and we're going to be taking a look at this RhinoCam part file in just a second. On the left there, you see the helmet, and on the right, you see Wyatt holding the end product. So this is a composite manufactured bicycle helmet from fiberglass. Now here we're looking at the helmet design in Rhino. So you have a number of views of the helmet. You have an outer shell, and then you have holes in the top, and then you have it trimmed, at the bottom. And you see that it's outfitted with foam inserts on the inside of the helmet. Now, how is this done in RhinoCam? Well, for composites technology, you may be familiar with composites in that it is a combination of resins and material that's mixed or laid in with the resin to harden. And in this case, the composite material is fiberglass. So what you need is a cavity in order to lay up the fiberglass composite material. So Wyatt designed two cavity blocks, right and left. If you look at the top left image here, you see the left side cavity block, and you see it represents one half of the helmet outer shell. So this is a negative cavity of the outer shell of the bicycle helmet. And then also you can see the trim line, the area where the composite will be trimmed after it's pulled out of the mold. So on the top right, we see the initial 2.5 axis facing operation and Z-level finishing to clear out the locator pin holes. And then in the bottom, where the action takes place on the bottom left, you see a Z-level roughing operation, or horizontal roughing, or so it's called. And it's done with a 12.7 1/2 inch diameter flat end mill to clear out the stock for the cavity. And then over here on the bottom right, we see two finishing operations. We have an initial Z-level finishing operation that gets a good finish on the sidewalls, and another operation of parallel finishing to get a good finish in the bottom area. And that's done with a 6.35 millimeter diameter ball mill. And we're going to be taking a look at this part here in just a second. So here on the left, we see Wyatt tending to his cavity molds. They're made out of 6 layers of MDF material, each side cavity. And what he's doing, he's preparing it for composite layup. So after it's machined out, he sands it, and then he polishes it, coats it in resin and then polishes it, and then sands it some more and gets it ready for the composite layup. On this slide, on the left, you see the bicycle helmet after it's been laid up with the fiberglass composite material. So that's it's coated in resin, and the materials fit into the cavity to form the outer shell of the bicycle helmet. And on the right, you see Wyatt, again, showing off his end result. Now, one thing else that I want to point out here too, the foam inserts, they use the same cavity mold for machining the foam insert. So they filled it with the foam, and then they machined out, a thickness 10, I think it's 10 millimeters thick from the outer shell offset, and then machined that out, and then fitted that foam insert into the helmet. Now, here again, we asked Kelsey, why RhinoCam? Why aren't you using something else? And the main reason here, obviously, is that they're using Rhino for their boat building and composites class. And obviously, RhinoCam is the obvious choice to run CAM inside of Rhino. The main obvious reasons is that it runs completely inside of Rhino. You don't need two different programs. You're not translating any part files from one program to another that can introduce errors. And your CAM files, your CAM program toolpaths are contained right in the Rhino part file. So you save the Rhino file, you load RhinoCam, and your CAM toolpaths are right there. So you make a change in the Rhino part, obviously it propagates to the toolpath. So that's the primary reason. And this is pretty cool here as well, and I wanted to tell you about this. On the left, you see IYRS alumni, and they're participating in the restoration of the Mayflower II. Now, in the 1950s, they built a full-size, full working replica of the Mayflower, and they dubbed it the Mayflower II. So in, I believe this was in 2015, I believe, they actually did a complete restoration of the Mayflower II, and IYRS alumni joined them in that effort at the Mystic Seaport in Mystic, Connecticut. And on the right, you see the Mayflower II being towed out of the Newport port to begin its sailing journey around the world. That's pretty cool. And also, there's a link here if you want to look at this video that talks about this whole restoration program and the IYRS alumni, how they participated in it. And I'll put this link actually in the description in the webinar replay, and you can link to it directly from there. Okay, if you want some more information about IYRS, School of Technology and Trades in Newport, Rhode Island, you can visit them online at iyrs.edu, and you can learn all about their program, the different classes, and you can sign up for classes, everything you could do directly from that website. And then on the right, if you want more information about RhinoCam, you can go to our RhinoCam product page, mecsoft.com/RhinoCam. So again, if anybody has any questions about these projects we're looking at, please put them in the chat window, and Joe will get them questions, or he'll get them answered, or he'll alert me, and we'll talk about them. Okay, here's the cool part. We're going to look at the actual student project parts inside of both Visual CAD/CAM and RhinoCam. So let's take a look at Sisters High School first. So I hope everyone can see that screen. This is Visual CAD CAM this is our own standalone Visual CAD CAM product. And what you're seeing is Visual CAM as a plugin inside of Visual CAD. So this is the model that was designed in SolidWorks and then opened up inside of Visual CAD. And the toolpaths that they use to machine this, let's just go through them here, and I'll show you the paths, and then I'll show you the cut material simulations and what makes this particular part interesting. Every part is interesting. It has its own unique characteristics and things that happen inside of Visual CAM and RhinoCam that make it a really interesting build. So let's go through the toolpaths initially. We have let's turn the toolpaths on. We have a Z-level roughing operation, and you can look at that in levels. You can just go down and look at each level in the cut material simulation or the toolpath simulation. So there is the initial horizontal roughing, and that roughing is done initially without adaptive roughing enabled. Now, adaptive roughing, that is a new enhancement we added just recently, which allows you to actually combine a re-roughing and a roughing operation in one operation. And what it does is goes back and analyzes the step downs and allows you to specify an additional step down distance to actually go out and take more material away from the part, all in the same operation. And we'll show you that in just a second. So here is the initial Z-level finishing operation without optimized XY machining enabled. And what you see here is that as the XY Z-level planes are sliced in order to calculate the toolpath, in the area that's near flat or just barely radiused on the neck, you see the widening between the toolpaths, and that's going to leave cusping along the neck, and it's going to leave a lot of cusping along here, which you would normally have to go through with another operation to clean that up. However, the same operation with optimized XY machining enabled, it's just a checkbox you turn on and you specify a step over distance, and you see that it calculates additional toolpaths to clear all of this material out and get a nice finish in one toolpath operation. And then we have a cleanup profiling operation to clean up the sides. So let's look at the cut material simulation. So here is our box stock for the neck. Zoom in a little bit. And here is our initial Z-level roughing. Let's turn the toolpath off. So you see a lot of stair stepping going on here. You can see it in this view over here. A lot of stair stepping, a lot of material being left here that you may want to go back and remove with another operation. Well, there's no need to do that. We just turn on adaptive roughing, and this is illustrated by this next operation. Same operation, just copied down with adaptive roughing enabled. And you see what it did was it cleared out a lot more material along here and along the neck area and along here as well. So that's all in one operation. Now, here in the Z-level finishing, this is without optimized XY machining enabled. And what you see, I mentioned the cusping areas around the near horizontal areas, it leaves a lot of material. So even though you might have a really tight step down in the Z level, it's still going to leave material because it's a large distance between the toolpaths in this area where it's near horizontal, and you can see it up here as well. So how does it look with optimized XY machining enabled? Again, this is just a checkbox, the same operation, turn the checkbox on, you give it a step over distance, and this is what you come up with. All of that material is removed. So you have your initial Z-level finishing, and then it goes in and adds additional tool paths in these areas. As you can see, here is the main cut level, here is the main cut level, and then it added all of these extra paths in there to clean that material up. So you can do that all in one operation. Okay, that's the Sisters High School ukulele neck. Let's take a look at RhinoCam from IYRS. Just one second. Okay, I hope y'all can see that. This is the left side cavity mold for Wyatt's bicycle helmet. And I have the bicycle helmet actual part actually shown here, so you can see that as well with the meshes, mesh wiring turned on. So this is the bicycle helmet. Now from that helmet, Wyatt designed a cavity. So there's two sides to this cavity. You have locator pins up here where the two sides line up to mount together. And then you have the actual cavity, left side cavity of the outer shell here in Rhino. So let's take a look at the tool paths. So initially we have a 2.5 axis facing operation that just uses the bottom perimeter as a containment area, and it clears off the top of the mold flush. And then we have a horizontal finishing that clears out the 4 locator pins. These are not through holes, these are actual full radius pin holes there. And then for the initial horizontal roughing operation, this is Z-level roughing in levels. So let's take a look at this. You can just get a good look there of the Z-levels. So this is Z-level roughing just to hog out all this material out and prepare it for finishing. So for finishing, initially we have a horizontal finishing operation again, and this is Z-level finishing, where it slices the part in XY planes in different depths in the Z-axis. So you have a nice step over here, but down in here the step overs get further and further apart, which leave cusping. And then for this particular part, I wanted to show you a combination of both. Rather than doing the optimized XY machining, I wanted to show you how you can use another operation in combination with the Z-level finishing to get a good finish on this part. So this is a Z-level finishing. The next operation is a parallel finishing along the same area. So in parallel finishing, the toolpath follows a straight line along either the X or the Y or whatever angle you tell it to follow. In this case, it's following along the X-axis, and it's just cleaning up, finishing this area, mostly in the bottom section here where it's got a lot of cusping left. So let's take a look at the cut material simulation for this. So let's go to the setup. So this is our box stock. Initially, we're going to clear the top off. Let's turn the toolpaths off so you can see this a little bit better. So this is our 2.5 axis facing, just to flush the top off. And then here is our horizontal finishing to clear out the 4 locator holes. And then we have our horizontal roughing to hog out the material of the cavity. Now this is the initial horizontal finishing or Z-level finishing in that same cavity. And you see that very good coverage up in the near vertical areas, okay, where the cut levels are spaced closest together. So if you give it a step down distance, that step down distance is going to be realized in the near vertical areas. So as it gets down closer to the horizontal areas, you start seeing the cusping going on. And typically in finishing, you would use a combination of two finishing operations, one to go one way and then one to go the opposite way to clean up that cavity. In the first operation, we're doing a horizontal finishing, and the second one, we're doing a parallel finishing. And you see how
Hey, Don,
nice. Yes.
there was a question on where do you turn on the optimized XY
Okay.
machining?
Okay.
And I actually posted a link to the blog article
Okay.
on Sisters Wear,
Okay.
but if you can quickly show it,
Yeah,
that'll be good.
let's go back to the Sisters High School one, and I'll show it to you there. Okay, so this is the ukulele neck, and let's go into the first horizontal finishing or Z-level finishing operation without optimized XY machining enabled. And this one has it enabled. So let's go into the toolpath dialog here. So for horizontal finishing, you got here's all your control parameter tabs. There's a tab called Optimize Machining, and you select that tab, and there's a checkbox right here to turn it on and off. So initially, you just turn it on, and you can provide it with additional parameters to control the step over that it's going to add in those areas. So here it's 0.03 or 30 thousandths step over. And you can also control the entry and exit, in the additional step over areas. So that's where it's enabled in the horizontal finishing dialog. Okay, hope I answered that. If not, we can get some more. As Joe mentioned, he put a link in the chat session to our blog post that talks about that specifically. Okay, let's go back over to RhinoCam for a second. So we talked about that. And in this particular, we didn't use the optimized XY machining. We wanted to show you how you can combine two operations to get really good coverage in a cavity area. Okay, so let's go back to the presentation here. I hope you guys can see that. And Joe, you want to take over and talk about the MecSoft products? Joe, can you hear
Let
me?
me do that. Thank you, Don. Thank you, Don. So I really quickly wanted to go over the products that we offered to the educational market and see if there's any fit for you, people who are watching this. So we do have two different configurations for the educational market or for the labs that you might have in schools. One is the professional and the other one is the premium. The professional goes all the way up to 3+2 and 4-axis machining. So if you're not doing any 5-axis continuous machining, professional would be the choice for you. But if you are doing 5-axis continuous, like some of our advanced universities are doing, the premium configuration would be the best option for you. We also offer different lab licenses in terms of the count. So we're starting with the 5-user lab license, and you can add on any number. You can go to 10, 20, 25, and in counts of 10, counts of 5 rather, increments of 5. But you can also, in special cases, we can give you some special numbers as well if you want. We also have a configuration called Campus Cam. Some of our universities are using that. That's a subscription, and it gives you unlimited licenses. As long as somebody's logged into the campus network, they'll be able to access our product. And that's a pretty good option if you have a lot of students using our product campus-wide, and they want to be able to access the product from anywhere they are, as long as they can get on that campus network. And in our website, you can actually evaluate, or you can download an evaluation copy of our product, and you can run through the entire set of functionality that we offer. And that'll be a very good starting point if you're brand new to our products or even CAD/CAM. And then functionality per configuration is how we offer it. So each configuration is tailored with different functionality. And then the product comparison you can use on our website to actually fit your application. There's a little tool in our website that allows you to do that. And then once you pass the initial evaluation stage and you want more in-depth information from us, we do offer one-on-one online demonstrations as well. So just call us and we'll be able to set that up. And typically these run about half an hour to an hour, depending on your questions. And we take one of your models if necessary, and then we can actually run through how we can use our products to program your parts. Don, next slide, please. And then we also, as far as customer support, which is a big requirement from our customer base, and one of our taglines, MecSoft taglines, is we are your CAM partner, which means that once we sell you a product, we just don't sell and run. We actually support our product. We stand behind it, and our customer support is is one of the best in the industry. We offer an annual maintenance subscription program where you subscribe annually, and you get every year we do a new release of the product, and you get the latest release, and so you're always on the latest release. The latest release will actually guarantee that your bugs are fixed. Any showstopper bugs and any critical bugs are fixed. Any new enhancements, we're always enhancing the product. You take advantage of that. Any new modules that come out, that we have certain modules that are only specific to maintenance customers, so you can take advantage of that as well. In fact, the 2020 release, we released a G-code editor module that is only available if you're on maintenance subscription. So there's a lot of perks for being on maintenance. You do get phone and email and login assistance with this maintenance. You also have access to our CamGem tutorials, which is over 70, I think minimum of 70 videos, tutorial videos that help you get started, as well as get more proficient with our products as you get more time and usage on our products. And then we do also have monthly training webinars. We call them AMS webinars that are very popular with our AMS customers. We go through frequently asked support questions. We tailor these webinars to go after some of the most often asked questions from our support forums, as well as our customers calling into our support line. And then, like I mentioned, we also have free early version releases with this annual maintenance. And then, and also I mentioned the access to the maintenance modules. But this AMS maintenance subscription is optional. You don't need to be on AMS. I know some of our customers, the cash flow might be a problem, so they choose not to be on AMS. In those cases, you do get free support. You have forum access. And then there's a whole host of YouTube channel tutorials that we update almost every week. So you have access to those tutorials as well. And then the forum is also pretty active, and there's a large customer interaction in the forum. So Don, next slide, please. As far as pricing and purchase, you can go to our MecSoft eStore. We have a product, educational product page specially. There's a special eStore for North America, and if you're in Europe or in the Eurozone, we have a special eStore for the European Eurozone as well. So our products are priced in euros for the Eurozone, and if neither one of these suits you, then just call us at sales at our sales line, or you send us email at sales@mecsoft.com, and we'll be able to answer any of your sales questions. And then I think we have one more slide, Don. And yeah, this is something that we are currently, with the launch of this webinar, we are also offering an upgrade sale. We can upgrade to the 2020 version from any older version for $599 for a 5-user seat. If you have a 5-user seat of maybe 2018 or 2017, doesn't matter how old your version is, you can update to the latest 2020 for $599 US dollars if you're in the US, and if you're in the Eurozone, it's €599. And then the same $899 for 10-user seat. So this is I believe this sale is only valid for about a week. So make sure you take advantage of this as soon as possible, because it's going to go away pretty quickly. So Don, next slide. Yeah, we'll leave it for Q&A, but also I quickly wanted to talk about our website. So Don, if you can bring up our website. Yeah, so if you go to MecSoft.com and then in the menu bar, if you go to industries, and you'll see education as one of the options. The last option is education. If you click on that, it'll take you to our educational portal. And then you can, on the left-hand side, you have that menu bar where the first option is the solutions that talks about the different solutions that I just mentioned in terms of premium and professional, and also the campus CAM. Pricing is the second entry in the menu where it talks about the different pricing. Already went through that. And then you can always go to our e-store, which is on the button up on top, at the top right on the always or at the bottom. Yeah, and I think Don already clicked on it. And then on the left-hand side, you'll see the educational product categories. If you click on it, that'll give you the different options and the different products that we have and the pricing. So Don, if you want to go back to the website. Yeah, and then of course we have customers, testimonials, case studies, a lot of our case studies that we have done, the educational case studies. We have testimonials from our customers. These are a customer list. As you can see, the list is quite extensive. A lot of Ivy League schools here in the U.S., University of California system, almost I think all the UCs have our product. And then the case studies, you can learn about how different schools are using our product, which is actually a pretty fun read. And then some of them actually have videos as well. Testimonials and galleries, again, show you, how our customers like our product. And there's some of them also leave emails, so you can actually talk to them if you want. And then the gallery shows you the different snapshots or the pictures that our customers have sent us on what they've created using our product. So this is also a pretty fun thing to look at. So if you have any questions other than what is presented on our website, always feel free to contact us at sales@MecSoft or support@MecSoft if you have a product related question. You can either call us or email us, and we're also on chat as well. So that's pretty much it. Don?
Any more questions coming in, Joe?
I don't see any more.
Okay, we're going to wrap it up, and I want to wish everyone a good day and stay safe. And we look forward to doing another CAM and education webinar in the near future. Y'all have a wonderful day. Thank you. Bye-bye.